Let's get started on our second part review for the review for final. And I'm going to start at 21. I think I did this one in class, but I'm going to start there. It says to express the null hypothesis and the alternative hypothesis in symbolic form. So we're reading for content. Carter Motor Company claims that a new sedan, the Libra, averages better than the 29 miles per gallon in the city. Use mu for the true average of the Libra. So as we're reading this, so we know it's for the population, and what they say on the advertising is that the average is going to be 29 miles per gallon. And then our alternate is going to be mu is better, so that means greater than 29 miles per gallon. And the one that suits that is not the first one because it says equal to. So it's not that one. I was fast, wasn't I? Less than or equal. No. It's D. So our answer is D. That matches what we took care of from the reading. All right. So here we're going to have a normal distribution with observations greater than 50. Find the critical Z value used to test the null hypothesis. So the very first thing I'm going to do is draw to understand. So we're talking critical value. So that's that value where we're going to measure against something, um, against what the test statistic is. So we have here alpha is 5% and is left-tailed. So we don't have to partition anything into half of the alpha. So if our alpha is 5% and it's left-tailed, then we know it's going to be a negative Z value. Because it's on the left of the mu, or whatever it is. So we're going to, of course, to find that Z-score, we're going to do second vars and we're going to choose number 3 because we have the area of alpha. And we're going to enter our area, our 0 and 1. And so that's what we'll do. Let's get our calculator out. I'll put it on the left. Oops, sorry about that. Second vars, number 3, decimal 0.5, enter, 0 and 1 for the commas, if that's what you're using on your calculator, and enter. And I get this value, negative 1.64485, and I do at least 4 decimals to see what we have a selection for. So we're going to, the most I see is 4, so it's a negative 1.645, which is A. All right, now this one here is indicating understanding. Right, indicating understanding of what we've learned in this section. Formulate the indicated conclusion in non-technical terms. That means we're not failing to reject or reject the null hypothesis. We're saying what was the claim and what do we mean by the solution. Be sure to address the original claim. So already we have the information that we need to do the original claim in the reference in our evaluation. Here it is. The principal of the middle school claims the test scores for the 7th graders of his school vary less than the test scores of the seventh graders in a neighboring school, which have variations described as the standard deviation is 14 and 7. All right, so we're talking standard deviations here. Assume that a hypothesis test of the claim has been concluded, and that the conclusion is reject the null hypothesis. State the conclusion in non-technical terms. So what we have here is that our H of O had to have been the standard deviation is 14.7 for all people taking this standardized testing. And what we found out, what we're claiming is that the standard deviation is less than 14 and 7. And so now we said, now this is our claim, and we reject the null. So we're rejecting this guy. So that means we're supporting this guy. So let's see which one states that. There is not sufficient evidence to support the claim that the standard deviation is greater than 14. Nope, greater was not even an issue. It was less. There is sufficient evidence to support the claim that the standard deviation is greater than. Nope, not that condition. There is not sufficient evidence to support the claim that the standard deviation is less than. Oh, but we rejected the null hypothesis, so it has to be D by default. There is sufficient evidence to support the claim that the standard deviation is less than 14.7. Good deal. All right, here we go. 24. This one is constructing the hypothesis, the null and alternative. All right, so we're going to read for content. A psychologist claims that more than 5 8/10% of the population suffer from professional problems due to extreme shyness. Use P, the true percentage of the population that suffers from extreme shyness. So, if there is more than 5 8/10%, then we have our H of O being, and it's a proportion, because it's a percent. So we know that. So the H of O says that our proportion is 5 8/10%, and our alternate, which is our claim, it is more than 5 8/10%. Not equal to, because it didn't say that. So let's look at the first one. H of O. P is 5 and 8. P is 5 and 8. P 5 and 8. All of them have the correct first null hypothesis. P is greater than 5 and 8. So that is our choice right there. We don't even have to go further. The other ones are don't fit the claim that we were addressing. So here we go. Okay. This one right here, use the given test to find the p-value. So this means we're looking to find the percentage under the curve. Also use a 5% significant level and state the conclusion about the null hypothesis. Reject or fail to reject. The test statistic is right-tailed and is 52 hundredths. Okay, so let's draw it. All right, so I've got this guy right here, and I have Z is 52. All right, so if this is, let's see, and this is, well, if we're doing a Z, it's usually a mu. And so this is 1, and right here is 0.52. Somewhere right here is our Z-score of 0.52. So we want to know this area right here. In comparison, now even by drawing it, we're going to see that we already know what's going to happen here. So we want this area, and then we have this 0.05 over here area at the right tail that we're comparing it to. So we're going to do an inverse norm. Because actually I lied. We're going to do, I apologize for that. We're going to do a CDF, a normal CDF. So we're going to go second bars, and we're going to choose, I think it's number 2. Yes. And we're going to enter our area, our low, our high, our standard deviation, which is going to be mu, and our standard deviation. So, okay, so we know we want this area on this side. So we're going to put the 5.52 z-score, 1E99, 0, and 1. Here we go. Number 2, 0.52, because we want right tailed. 1 second E99, 0, 1, and enter. And we get decimal 30153, blah, blah, blah. And the one we have is 15, so we did 4 decimal places. So it's between this one and this one. So which one? Okay, so now we're going to compare it. And our significant level was 0.05. And it's greater. Well, if it's greater, what do? We fail to reject because it's in the acceptable norm. So it's A. And that is because it lies within acceptable boundary. So we fail to reject. All right. This next one, we're going to have to use the chart. And we're not going to have it on the exam. So, but we are going to have 27. Well, we're going to have possibly 27 because it is another analysis. You won't have all the analysis ones, but you'll have one of the ones I've listed. An entomologist, there it is, entomologist writes an article in a scientific journal which claims that fewer than 7 in 10,000 male fireflies are unable to produce light due to genetic mutation. So, that's the claim. Assuming that a hypothesis test to support this claim has been conducted, and that the conclusion is to reject the null hypothesis. So then, if we reject the null hypothesis, we support the claim. in non-technical terms. So there is sufficient evidence to support the claim that the true proportion is greater than 7 in 1,000. That sounds very good. There is sufficient evidence to support the claim that the true proportion is less than 7, fewer than 7. This one is greater and this one is less. It's B. Sorry, misread it. All right. They're not hard because we've done so many problems that it's become easier, I'm sure. Here we are on 28. On 28, we have one where we're identify the null hypothesis, the alternative hypothesis, the test statistic, the p-value, and the conclusion. All right, here we go. A supplier of digital memory cards claims that no more than 1%, no more than 1%. So that's less than or equal to, isn't it? No more than 1% of the cards are defective. In a random sample, 600 memory cards, that's the quantity. So we have our H of O is, it's a proportion because it's a percent. P equals 0.01. Our alternate hypothesis is P is less than or equal to 0.1. No more than. That means it can be 1, but it can't be greater than 1. All right, does everybody understand that? Okay. So that's what we have right there. And then it says our N is 600 memory cards. And they found 3% defective. But the supplier claims that this is only a sample fluctuation. At the 1% level of significance level, test the supplier's claim that no more than 1% are defective. So we need a z-score. Because it's a proportion. And we're going to have our p hat minus our p divided by the square root of PQ divided by N. That's our standard deviation type on a proportion. And we're looking at what our test statistic is. So our p hat is our sample, which was 3%, minus our p, which is calculated at 1%, divided by the 0.01 times the 0.99, which is 1 minus the 0.01, divided by that 600. All right, so let's do our item. Okay, so I'm going to put open parentheses, decimal 0.3 minus the decimal 0.1, close parenthesis, divided by second square root of 0.01 times 0.99 to give me the 1%, divided by the 600 of our sample. And we get our test statistic. It's very large, 4.92365, blah, blah, blah. Okay, so we want to put 2 decimal places. Is our test statistic. Now it said to find the p-value. This is our test statistic. And so we're talking about greater than or equal to. All right. So in this case, we're going to do second bars. Choose number 2. All right, now what kind of parameters am I looking at, right? So it's saying, let's talk about the claim, all right, that no more than, so it is less, right? And our significant level, so that makes it a left tail, doesn't it? Because our significant level is 0.01. That's our significant level. And we have a test statistic. Oh, we're on this side, sorry. Okay. Because it's only that part. Sorry about that. We have a positive on our test statistic. So we want where this 4.09 measures. This is our significant level, and I'm thinking it's in that group. Somewhere in there is some z equal to 4.92. All right, so let's see what kind of area we have. And we want it in the left. So this is my low, and the 1E99 is my high to find that area. All right, here we go. Here. Second bars, number 2. And I'm going to put the 4.92, the 1E9901, and enter. And I get a very tiny area. So this is going to be 4.92. Let me use the blue. And here's one of those scenarios where you have to read the calculator correctly. Notice it says 4.33 and so on, but it says times 10 to the negative 7, very, very tiny. So that is 0. That rounds to 0. So now we're measuring 0 against, I better write it as Yvonne, give you the step. Hold that thought. So now that we know that it is in comparison to the critical number, so now we're going to compare the p-value to our significant level. All right, our p-value is 0, and we're comparing it to 0.01. Well, 0 is less than 0.01. So reject the null hypothesis. So that's what we're doing on that criteria. And any way you write it for me is going to be okay. So you're going to have to say we reject the null hypothesis, and because there's we reject the null hypothesis, and since there are no more than is used, therefore the hypothesis is that p is greater than 0.01. And whatever you write for me would be okay. Now we have this one. 29. And in 29, we have a sample of 76. Um, we have a sample of 76 adults selected randomly from one town. It is found that 12 of them have been exposed to a particular strain of flu. Find the p-value of the test to reject the claim that the proportion of all adults in the town that have been exposed to this strain of flu is 8%. Okay, so we have a H of O that says our proportion, because it's a percent, is 0.08. And then we need our best estimate. Our p hat is going to be our x, which is 12 out of 76. So we're going to do that math just so we know what it is. And we know what our claim is. It is 15%. So our claim is that P is greater than 0.8%. All right, because we've got a 15 and some on that guy. So in this case, we're saying we have a mu, P, and we have a test statistic. And our test statistic is going to be, let's see, we want to find the p-value. And our p-value for a test to reject the claim that the proportion of all adults is 8. All right, so we're going to do a test, and I should give it both. Stats, test, and on our test, this is a proportion. So we're looking for one proportion z-test, because that's what we have. And I think we can do it here. Let's try this one out. Our P of O is 0.08. Our X is 12. Our N is 76. Our proportion is greater. And we're going to calculate. All right. Our test statistic is a z-score of 2.503, blah, blah, blah. So it's 2.5. Our p-value is 0.00615, blah, blah, blah. All right. So now what we're going to do, because we got the two values, now we're going to say with a strain of 8%, find the p-value for a test to reject the claim and the proportion of all the town have been exposed to strain of flu is that. So in this case, we're saying our p-value is 0.0062 right there. All they wanted was the p-value. And it is, yeah, that's what it is. In 32. So I think we got that, right? Let me look on the answer key to make sure I'm giving you the right answer. 30, yeah. It's supposed to be this one, so it's got to be something oh, we have to double it because it's one-sided. That's what it is. So that's going to give me 0, 1, 2, and that should be a 2, so it would be a 4. And it's this one. There you go. Man, I made a mistake. Not reading carefully. What can I tell you? All right, that's why I have an answer key on the side. Make sure I mess up or forget one thing in statistics. Assume the simple random sample has been selected from a normally distributed population, so forth. Use a traditional method or a p-value method to, as indicated, identify the null, alternate hypothesis, a test statistic, critical values or p-value as appropriate, and state the final conclusion. This is the entire package for 30. So let's see what we've got. Oops. Oh, just a second. I got to plug in my computer. All right. So it says a significance level of alpha. All right, let's see what it says. Use a significant level of alpha equal to 0.01 to test the claim that, okay, my H of O is mu equals 2 and 8500ths. Our alternate is mu is greater than 2 and 8500. The sample data consists of 9 scores. And the X bar is 3 and 1300ths. And our standard deviation for the sample is 5500ths. Use a traditional method of hypothesis. Okay, because we have the standard deviation for a sample, we're going to do the t-test. So we're going to go to stats, test, and let's see which one we're going to choose here. Stat, test, and this is a t-test. T-test, right there, number 2. And we have data. Our mu is 2 and 8500ths. Oh, we got to do stats. Sorry about that. Stats. Our mu is 8500. Our X bar is 3 and 1300ths. Our standard deviation for our sample is 55. Our N is 9. And we're saying mu is greater. So that one's good. And we calculate. Oops. Let me do it again. I went too fast once I calculated. There we go. So what we have here is they wanted the p-value or whatever we got. So our test statistic is t equals 1.53. Our p value is 0.083. I'm going to do 3. I don't know what the answer key says yet. And then it wanted, and then let's see what it said. Okay, so we have a significance level of 0.01. So our p-value is 0.083 compared to 0.01. It is greater. So what do? We fail to reject. Isn't that what we do? So on this case, okay, and I think that's all. And state a conclusion. So there is sufficient there is sufficient. That's the word they use. Sufficient. I keep on forgetting that. Evidence to um, to reject the claim that mu is greater than 2.85. All right. This last one has data. And on this one, we're going to be doing stat, edit, and enter the data. So let's do that first. It's not a big problem, so we got a good thing. I'm going to clear. Okay, stat, edit. I have stuff in my line 1, clear enter, 518, 499, 548, 538, 561, 557, 523, 528, 536, and 5663. Okay, entered everything right. All right. So now I'm going to do a test for this guy. Let's read what we have. I entered the data. It says, it's found that the mean time between failures is 520 hours. And this is a 520 hours is the mean. So we have our H of O. A modification is made to support the increase of the time between failures. Test on a random sample of 10 resulted with the following times. Significance level is 0.05. The test claim for the modified components, the mean time between failures is greater than 520 hours. Use the p-value method of the testing hypothesis. All right. So what would I do with this guy right here? Well, I've got data, and I can enter it because I'm going to get, I think, everything I need. I think it's under a test. Let's look at that. So I want to go to the test, and I have a proportion, so it's a z-test, and I have data. And in this case, I have my mu is 520. My standard deviation is I'm going to say that I'm guessing, I don't know what it is. I'm going to leave it at, let me read. So I'm guessing that if we do it on the sample, it's going to come out to be the mean, the standard. I'm going to say, let me do this. Let me do the stats. Let me do calc. Let me figure that out. Standard deviation is 20 in that piece. So what would we say it is? Maybe I should do it by hand. Should I do it by hand? Well, it's got me puzzled a little bit. Let me look at the... It's a T. It's a T test. All right. So we're going to go stat, test, T test. Because I have the data, but I don't have the standard deviation. So I'm going to do a t-test. That's what it was. And I have stats, no, data, 520, line 1, frequency, oops. Okay, number 2, data, 520, line 1. And we want greater. That's okay, that's good. And we want to calculate. All right, there it is. And what we have here, they wanted, well, let's just do the test statistic. T equals 2.61. Our p-value is 0.014, small. And I don't think we need anything else. Now we have a significance level of 0.5 and our N is 10. So we're saying, and this is greater one tail. So 0.0414 is less than 0.05. So we reject the null hypothesis. And then we write this. We write that there is sufficient evidence to support the claim that the times of failures occur greater than 520 hours. So there's enough to support that. And that takes the end of it. Thank you very much for listening. I make a note that if we don't have the standard deviation for the population, we have to do a t-test, and I need that, but I had to look at my notes for it. And so I would make a note of that for yourself as well. Everything else was cut and dry, everything. Thank you very much.